Okay, so you can start the recording. Okay, so today topic will be on bivariate analysis. Yesterday we have seen the univariate. Okay, how we did the analysis on single variable or feature or column. Okay, we'll just recap what we have learned. Okay, give me a minute. Let me open univariate. So univariate stands for one variable. Okay, focuses on analyzing variable at a time to understand its distribution, spread, okay, spread and central tendency, like mean, mode, median, standard deviation, and frequency. Okay, so we worked on some sample data yesterday, and we just played around with one column. Okay, you can see here df colon square bracket. I'm taking only one column. Okay, univariate analysis means you are doing the analysis for only one column. Okay, it could be categorical, it could be numeric value. Okay, so we have seen this with hist plot, how the data is spread. Okay, and you can see the skewness, and you can see the bins, how many bins we have used here. Okay, so 6 bins I have used. You can use 10, 20. Okay, so that you can see your data value points. Okay, and also we have seen box plot to identify if there are any outliers, plus how my data looks like. Okay, it looks uniform. Okay, and there's a violin plot. Okay, and if the bulge is like one-sided, or if the bulge is like it goes above this line and all, right, that means you have some outliers. Okay, so basically we do all with one column or in the entire data also. So one column, why we are doing is, this is important when you want to do the analysis for particular field. Okay, you have gender, marks, and age. So you can, I did this all three yesterday. So this is the count, and here you see gender we are using. Okay, now what is the gender? It's a categorical value, and you can see we are getting with value count feature, we are getting the count of how many male and female counts are there. Okay, same thing we visualize this with uh, count plot. Okay, male is dominating here. Okay, then female, and this is the pie chart, and this is the code. Okay, so see, only thing is you have to change this column, that's it. Okay, so if you have a categorical data, okay, some other like state, and then country. Okay, so you'll get the correct picture in a pie. Okay, only thing is you have to keep all this code intact, and whenever you get scenarios or depict or visualize the categorical, you can use the same code. Just copy this, change this field, and change the title, whatever the title I have given here. If you might be having a different one based on your data set. Okay, and you want to change the color, you can change the color from sky blue, pink to some other color based on your requirement. Okay, and also we have seen skewness and kurtosis. So what it says is that as per the formula of skewness, if your skewness is greater than 0, okay, then we say your data is right skewed. Okay, if it is less than 0, means if it is in going in minus, then we say it's a left skewed. Now you see here 0.08, so it's a right skewed. Same thing for kurtosis. Okay, we're gonna cover these 2 points in these two topics in what is that, machine learning. Okay, so machine learning, we will touch base all these things again, because these are the topics that you'll be using in your ML analysis, machine learning analysis. Okay, same thing formula I've done. Those who have missed out, please go through those videos that Saab has uploaded, and you can very well connect with these topics. Okay, so today's topic is on bivariate. Okay, bivariate analysis. So what's the objective here with bivariate analysis? Okay, so what does it do? Okay, bivariate analysis helps you study. Okay, it helps you study or analyze the relationship between two variables. Now, what is this two variable columns? Okay, say you have an Excel sheet, you have 10 columns. Okay, and you want to do the analysis based on two columns. Okay, you can pick if it is a numeric, you can pick if it is a non-numeric like categorical, you can still do the analysis like whatever we did in yeah, univariate analysis. Okay, but here the approach will be little different from univariate. Okay, so to study the relationship between two variables, whether they move together. Okay, so this is the point here, whether they move together. Say for example, you have marketing and you have another column called sales. Okay, you are spending XYZ amount on marketing. Okay, and the results is there on the right hand side column, which is called sales. Okay, and though you are spending more, but your sales are not improving. Okay, so you can do the analysis of bivariate whether they move together, depend on each other. Okay, you can also do the analysis whether these variables, two variables A and B depend on each other or have patterns. Okay, worth exploring. Okay, I'll just add this statement here. Okay, bivariate analysis helps to study the relationship, study or do the analysis, the relationship between two variables, whether they move together, depend on each other, or have patterns. Okay, now what we'll do is, now, what are the type of bivariate analysis? Okay, what is bivariate analysis? We know it means 1 minute. I'll just add this. Okay, so it means um you can do the analysis for numeric, categorical, okay, or categorical to numerical and numerical to numeric and categorical to categorical data. Okay, and examples, I'll just give the examples, I'll just add it here. Okay, so I've written already in a notepad, so I'll don't want to waste time here. Okay, so types of variable, what analysis you can do by variate. One is numeric to numerical, categorical to numerical, and categorical to categorical. Okay, gender versus stream, gender versus marks, marks versus study hours. Okay, check correlation, trend, compare average. Okay, compare frequencies. Frequency is nothing but how many times it is repeated. Clear, guys? Yes, no? Okay. Now I'll take a sample data now. I'll take some sample data. 1 minute. Yesterday's yesterday's same sample data. I'll take. Okay, we don't have stream here. Okay, 1 minute. I should have on my notepad. 1 minute. Okay, got it. Okay, same thing. You know this libraries that you have to import: pandas, seaborn, matplotlib, and numpy. Okay, and this is the data. I'm creating a data frame here, dictionary type. Okay, you have a key and you have a value point here. Okay, so I have name, gender, study hours, marks, and stream. Okay, now I have added something called stream here. Okay, stream means subject. Okay, science, commerce, science, arts, science. Okay, some random thing I took it. Okay, and then I'm converting that data into a data frame using a data frame function, and I'm passing on this data inside this braces to convert, and I'm storing it in a variable called df, and I'm displaying a df here. So I'll run it. Okay, so this is the data point. Okay, so these are all data. So I have my study hours, marks is in numeric. Okay, and this is categorical. This is categorical and this is also categorical. Okay, so now we'll do a analysis. Bivariate. Today's topic is on bivariate, means two columns. Okay, first we'll do a numerical to numeric. Okay, numerical this one and this one. Okay, so let me make a label here. Okay, so what we'll do is we'll start with scatter plot. Okay, scatter plot. Okay, so I'll say SNS dot scatter. Yeah, scatter plot. So this is a function I'm going to use, scatter plot. So whenever you have a function, the first thing what you have to do is you have to pass your x and y. Scatter plot, you know, right, with a dots, and it has x value and y value. Okay, so here you have two values, x equals. So first label that I want to pass here is study hours. Okay, I'll just copy. Okay, and then I'll put a comma and I need a y value. Okay, y axis value, which is marks. Okay, which is marks. And so I also have to pass my data. Okay, data is equal to, where is my data stored right now? In a variable called df. So I'll pass this here, df. Okay, now second thing what comes, the title, and then you have to display. So how will you add a title? You'll use plt dot title. I'll give some random. So it's a two bivariate, right? So I'll say study hours versus what is that, marks. Okay, so this is the title, and then I want to uh, use the show method to display the scatter plot. Okay, I'll run this. Okay, now you see. Now how do you interpret this? Okay, now the point is going like this, linear. Okay, and now you see all variable are all variable. Okay, yeah, see, yeah, here first here. Okay, so he can see here what is this, steady hours. Okay, you have some values and you have some marks values here. Okay, so what this indicates is marks and steady hours. Okay, you can see the scale here, it starts from 2 hours. Okay, if you see the number here, 2 is the least. Okay, so if you study 2 hours, you get 65 score. Okay, and you can see it is increasing. Okay, so scatter plot sometimes is very useful when you want to do a bivariate analysis for two variables. Okay, now it is going something like this. So that means the more, how do you interpret? You will interpret the more hours you are spending on your study hours, the more score you're gonna get in exams. Okay, and the trend that you see is positive. Okay, so the trend is positive, more study hour means higher marks. Okay, and also outliers also can be detected here. This, okay, this is one, this one and this one. Okay, if you see all are with 2 points. Okay, so this way you can find out, or you can also do the uh, I'll just copy this for now. Okay, marks. Okay, so it starts from 65 to 90. Okay, so what is the other one? Study hours, right? Study hours. Just copy the label and I'll put it here. Study hours, study hours. Okay, now you see that there are no outliers here. Okay, so out of these two whisker left and right, you don't see any dots here. So if you have any dot, So you can say there are some outliers. Since in this case there are no outliers by seeing this data and it is a positive trend. Okay, when your data points are in a linear like this line, straight line, then we say it's a positive trend. Okay, now we'll do one more thing. Now we'll see the correlation coefficient. Correlation coefficient. Okay, now correlation coefficient. So how do we find out the correlation between two variables? Okay, two columns or two variables. So how do we do that? We use df square braces. Then again you have to use square braces. Inside you have to write the first column, which is study hours, and marks. Okay, so you have to use two curly braces. Okay, and then how do you do the correlation? You will put a dot and then okay, let's type correlation, corr. Okay, this is the function we're gonna use. So we'll not pass any parameter right now. We'll just close this and we'll run it. Okay, now you see the study hour is 1.0, which is 98%. This one, okay, 98%. And the second analysis is marks. Okay, so marks is 98 if your hours are increasing. Okay, and how do you correlate here? I can say I see a strong positive correlation of 0.98. Okay, marks increases with study hours. Simple. Okay, 98. So I'll write down the interpretation. Zero point 0.98. Okay, correlation of 9. And I can say what I can interpret is I can say marks marks increases INC. Okay, 1 minute. INC REA increases, marks increases with study hours. Okay, so this is the interpretation I can draw here. So I'll just add it here. Okay, so this is one correlation also we learned. Okay, and how do you interpret? Okay, so you see a strong correlation. Okay, here and here you see strong correlation between study hours and marks. Okay, do we have any other numeric number here? Nope, we have categorical only. If we have one more, right, we can do the correlation, but we will play around with other data set real time and then we'll see how it goes. Okay, now we'll plot the reg plot. Reg plot is which is called a regression line plot. Okay, these are all high funda that we're gonna learn in machine learning and all that, regression, classification, and all this. Regression plot. Okay, regression line plot. So how do we do that? We'll use the SNS library dot. I'll type the first three letter reg plot. Okay, again reg plot will take x value and y value. Okay, so I have already typed this before for this one, okay. So I'll just copy this for now, and this also. Okay, same data, same line you can copy. Okay, 1 minute, I'll just delete this. Yeah. Okay, so this is the first line, and second one is what line we will add next is title. So how do we do the title? Plt dot title inside braces, we'll say study versus our study hours versus marks. Okay, and then we need to display. So what is the command? Plt dot show. Okay, now see before and after the line chart and sorry, scatter plot and regression is you have a line here. Okay, that's a difference. And what we have to identify here is these dots. Okay, these are all data points, and you have to see how much far from this line. Okay, now this one we can relate. This one is touching, yes, and this one is little skeptical. Okay, 4 hours and marks is 70 78 or 79. Okay, so this point sorry, 74. Okay, so if this line is somewhere here, then we can say this data point is also positive. Okay, these are little away, and you can see most of them are almost near to this line. Okay, that is what we have to interpret this, how we have to, or you can say uh, I mean, it's a regression plot. What it is doing is a trend line showing the relationship, strength, and direction. Okay, but this data point that you see, if it is somewhere here, okay, not near to this line or nearby, then we say this particular there is no relation. Okay, for that hours. Okay, 5 hours and 95 or 100 cannot be justified. Okay, so this is how you're going to interpret with regression. You can do it for example, support ticket you have. Okay, you are closing some tickets. Okay, so you have a ticket details. Okay, when you received date wise, and then what time you closed it. Okay, so if you can depict that in this regression line, you can do that, and you can see if there are some data point like uh, Wednesday some 10 tickets were closed. Okay, those took some 90 minutes to close the ticket. Okay, but the same ticket next day they are closing it within a line. If the data point is somewhere here, then you can interpret. Okay, and you can when you can interpret based on your data points. Okay, now what we'll do is this scatter plot is done, regression is done. We will do the pair plot. Yeah, pair. See, these are all important when we are doing a bivariate. Okay, these plots. So I'll say SNS dot pair plot. Okay, I'll use the pair plot, and what are the parameters it will take? It will take the data frame, which is our data, entire data, and I need to pick the variables. What variables I need to pick from that entire DF? I know we have 5 columns, 4 columns, right? Name, then student name, hours, marks, and what is the other one? We have one more, right? Okay, I'll just type it here. DF. So I have how many? One, two, three, four, five columns. I have categorical this stream, this, and gender. Okay. So whenever you are using a pair plot, okay, you can use where this is the parameter it will take, and here you have to mention the columns that you want to do the analysis. Okay. In this case, I'm going to do for study hours and marks. Okay. I'll just copy this. Okay. Study hours, marks. Yes. Okay. And then I'll put a comma here and hue. Okay. Based on which parameter I want to check this. Who is studying more? Okay. And who is scoring more? Hue is equal to, I'll use gender. Okay. And now what I have to do, I have to use the title. PLT dot, what is that? PLT dot title. PLT dot title. I'll give some dummy. Uh, pair plot analysis. Pair plot analysis. Okay. Then plt dot show. Okay, let me just get rid of this. Okay, now you see I have a beautiful pair plot analysis. Okay, now it is overlapped here. I don't know why. Okay, for now I'll just remove it. Let's not think more about it. Okay. Now you see, I have a gender because I use something called hue here. Okay, based on gender, I want this steady hours and marks. Okay, now blue means male, and this amber means female. Now you see, who are studying more? Steady hours. Okay, female. Okay, and here study hours, female, female, female. Okay, orange versus blue. Okay, there are one male person who is also at the top. And marks, you see, so average 95% is what they are scoring, female, and you can see blue dot here at the top. So male students are securing more. Okay, so that is the interpretation that you can draw. Okay, and you can see this pair plot usages. You can see all pairwise relationship in one grid. Okay, these are four grid. Okay, but if you see it is arranged in a one small grid where you can compare all together. Okay, on different parameter. This is study hours and this is marks. Okay, that is why we say pair plot. Pair means you cannot pair with one variable here. Study hours only you cannot do. You need two, marks and study hours. Okay, now we'll see the uh, categorical versus numerical. Okay, now we have seen all numeric. Now we'll see what's the time, 9:20. Okay, we can spend another 10 minutes. H3, I'll just name this as categorical versus numeric. Okay, now what does it do? It is used to compare how numeric data varies across categories. Okay, generally, see, if you see your data, you cannot have all numeric fields. Definitely you'll have some categorical: location, state, country, right? So so we need to know the techniques and or approach how to tackle the categorical versus numeric. Okay, so in our first example we'll use box plot. So let's start. 1 minute. Okay, I have to select the second one. Okay, sms dot box plot. In box plot, what are the parameters that we can take? Two parameters. Okay, x and y. X is equal to gender and y is equal to marks, and I have to point the data. Okay, so where is my data all stored? In df data frame. Okay, this is my first line done. Then I'll add the title. Then I'll give marks by gender. And the last one is plt.show function. Okay, it will display. So let me run this. Okay, now you see. Okay, in male we don't see any outliers, but in female we see outlier here. Okay, so the box plot is very useful visualization where you can find the outliers in your data set. Okay, so how do I interpret this data? Okay, I can say the median line shows the central tendency. This median line shows the central tendency. Okay, for male, so this is the median. Median is mid value. Mid value is where? Close to 75. Okay, and highest point here is 85, some 86. Okay, 86 or 87. Okay, and lowest point is here at 71. Okay, and this one female, you see in the point here, right? So the average is 84, the median, and this is 25% bucket, and this is 50%, and this is 75% bucket. Okay, 75% of the female out of the list we have are falling under what number? 86% marks. Okay, that is how you're going to interpret. So median line shows central tendency, and box height shows spread. Okay, this shows the spread of your IQR interquartile range. Yesterday we have seen, right? So you can do that also formula, or you can use the box plot. Okay, and the outlier dot shows unusual values. This dot. Okay, generally we'll have a whisker. This is called a whisker. Okay, left, down, up. Okay, so what is the max number that it is touching? Somewhere 93, 94. Okay, lowest number is 65. So we are comparing with gender here. Okay, not with study hours. Gender. So if you see, male are securing more score than female students. Simple. Okay, and then now we'll see the violin plot. Let me go this copy. Okay, now you see. So what I'm doing is now I'm taking x is equal to stream. Okay, if you see our data set, we have one more categorical data called stream. Okay, now what are the stream? Science, commerce, and arts. Three groups. Okay, in graduation, if you see, we have three groups. Okay, and y is equal to marks. Okay, now whatever you see at the center, right? What is this? This is nothing but a box plot. Okay, and then the white line that you see here, this is your median. Okay, and this is the whisker line, and the for science, so this is the 170 and highest marks is 92. Okay, for commerce, the marks that people are securing the minimum is 1 minute. Minimum is somewhere 74. Okay, and maximum is 90. Same thing you have to compare with this. Okay, this is very useful, guys. Okay, so it will give you, see, categorical versus uh, marks. Okay, we'll do one more. Okay, now bar plot. We have already seen yesterday also bar plot. Okay, the same code I have copied and I have made some changes for our session so that we'll not waste or spend time in typing the same code again and again. So I've kept it some codes in a notepad so that we can save some time. Okay, so I'll explain this first line. SNS is nothing but your Seaborn library dot bar plot we are using. This is called a bar plot where you'll see a line here. Okay, and here I'm taking two values, gender and marks. This is marks, this is gender. Okay, and the data points where it is stored in df, and estimator is equal to mean. I'm checking np dot mean numeric, this is numpy. Okay, np dot mean. Okay, and there's a title and there's some display. Okay, so this is one. So this is useful to compare a mean values across categories. Okay, we have one more called cross tab. Okay, so this is pandas pd dot. Okay, we have to pick the column here. Okay, so if you see all this visualization, right, so there is a different parameter that you have to pass in. Okay, some will take x value, some will take y value. Okay, some will take a different parameter. So once you practice this, right, with the data, or you keep it safe, whenever you want to refer, you can refer and pick up your data there. Okay, so this is how I do. Okay, you can also start doing that. Okay, I'll pick first one is df gender, comma, I'll take another, and here I'll take stream, stream stream. Okay, so I want to see gender and stream. Is there any uh, uh, so this one, what I'm doing is, see, this is, yeah, I forgot to add, this is categorical versus categorical. Okay, okay, now you see, under arts you have two female and male. Okay, under commerce you have two female, one in male. Okay, science, nobody is there from female student, all are male. Okay, cross tab will give you this count of difference between two variables. Okay, these are all very useful, guys, for you. Cross tab, this visualization that we just saw, box plot, bar plot, scatter plot, regression plots. Okay, and we'll do the another one called heat map. Okay, so heat map. Okay, so simple, sns dot heat map you have to type. Okay, and then it will take open and close, and these are the parameter. Okay, now what I'm doing is I'm passing the same command. Okay, pd dot cross tab, same thing, comma, annotation, annote is equal to true, and CMap is equal to, this is a color code. Okay, you will find it in Python documentation, or you can save this, you can use the same format, and this is a title and displaying the result. Okay, now this is how it looks like. Whatever the item I've added here, these are the color points. Okay, colors, color pattern for this result. Okay, what if you don't give? It will take a default color. Okay, it will take a, this is the default color: red, black, brown, and this cyan. Okay, so this is the default color it will take. It's up to you guys. Okay, so you don't want to color code, you can do that. Now how do you interpret this? Okay, this is a cross tab, female 2 and stream, this is commerce. Okay, 2 1 2 1 0, female is 0 in size and 4 are male. Okay, this is another way to count your values here. Okay, so now how do you interpret? It shows count using color intensity. Okay, this in color, this color, this color, this color. Okay, and what does that mean? The darker means more frequent. Darker. Okay, darker means you can see it is in plus. Okay, the lighter means less frequent. That is how you have to interpret the heat map. Okay, there is one more called clustered. Okay, clustered uh, distribution. Okay, now you see science, commerce stream. This is male and female. We are taking gender and arts. Okay, so this is also very important. This code, just make sure you save it in a proper way so that you can make use of all these things later on. Okay, so this is a clustered bar chart. Okay, how do you use? You can use the count plot. Okay, only thing is here you are using as hue is equal to gender. Simple, nothing else. Okay, I'll just add some more cell here. So this is another heat map. So what I'm using the data here is df.correlation, the previous one which we have already done. Okay, so correlation. Okay, so it says could not convert string to float, a myth. Correlation heat map. Okay, I can use one minute, not gender, sorry, hours and hours, where is study hours and study hours and marks. Key error, why? Okay, that's fine. I'll just check this later and then I will add it. Okay, and you can do the pair plot also. Pair SNS.pair plot df hue is equal to gender and simple one line command. Same thing we have done before. Same thing. I've written all these things, but one thing didn't work. I'll just check later on and I'll update. Okay, so relationship numeric to numeric, detect correlation, linearity, categorical to numeric, compare, group, means and medians like box plot, bar plot, violin plot, categorical to cortical, crosstab, count plot, and heat map. Okay, so this is about the bivariate analysis, and so what is the conclusion is bivariate analysis is the core of EDA, exploratory data analysis. What it does is it bridges your data understanding and predictive insights. Okay, so this is about today's topic bivariate. So we will conclude with next topic tomorrow. Okay, next topic would be on 1 minute. Okay, multivariate analysis. Okay, and then we have feature engineering. Okay, feature engineering, and then data visualization and insight. So these are the topics. Okay, Saib, you can close the, you can stop the recording, and let me give me 1 minute. I'll share this sheet with you guys. Okay, this is very important. Uh, by now, whatever we have learned, right, you can start working on your data. I'm telling you, by now we have done a lot. Okay, I've shared the files with you guys. Okay, save it somewhere and then you can start working on it. Okay, chalo then we'll close this session. We're on top of the hour, so we will meet again tomorrow, same time. Okay, please practice, pick some data and start working. Chalo, bye. Good night.